Hello and welcome to Math 252, Calculus 2 here at Cañada College. My name is Lapuz. In this video we'll go over checkpoint 5.12. This is coming from section 5.3. So they want us to say what this series or what happens to the series based on the divergence test. So our divergence test tells us that if we have a sequence a sub n, and you take the limit of that as n goes off to infinity, and if it's equal to any number or anything that's not equal to 0, then this series itself diverges. Okay, so it has to be equal to 0. Now, one caveat about this divergence test is that if it is equal to 0, if that limit is equal to 0, then you know that it might not diverge, which means it could converge, but it could still diverge. So you have to be careful about using this test. This test only says, it's test for divergence, so this test only says that if the limit does not go to 0, then it diverges. If it does go to 0, all bets are off. We don't know anything about this. We'll have to use another test. Okay, so let's figure out what's happening with this particular example. And in this example, we have cosine of 1 over n squared, and we want the limit as n goes to infinity of this particular graph. Now, I don't know what this graph looks like necessarily, but I know that the cosine 1 over n squared, as n goes to 0 or n goes off to infinity, then that means this whole expression here goes to 0, and we know that cosine of 0 is equal to 1. So I'm not sure exactly what happens, but it looks like it'll be approaching 1. Okay, so if we follow that pattern over here, this is going to approach 1, and more importantly, it's not equal to 0. So at this point, this series, if we look at this as a series, not as a sequence, but as a series, the series from n goes to 1 to infinity of cosine 1 over n squared is going to diverge. And that's going to be our conclusion. All right, I hope that helps. Good luck.